Okay, good morning. So if you want to join, please scan the QR code. Okay, so I'm not sure about the Teams. Later, if I want to use it, we will restart Teams. I guess so. So that's why I mentioned Teams. I have something wrong with Teams. All right, so last week we already have the checking of the videos. And of course, ask you to have the answer in here. Today, no, it won't be necessary to join this. So we jump to this one. It's finished. Well, I'm not sure why it's clear, but let me check. Okay. So you have the answer like this. So first of all, this one. But correct or not, let me try to find one serving as the suitable one. For example, this one. In fact, what it means socket. Socket in our slides we call it like a door. Because of door, and then we can have some action like 1, 2, right? All right, so something like this. All right, so here, right? I asked tutor to grade, but I'm not sure tutor follow the principle to have the proper grading or not. But at least it looks like a door because socket originally it should be socket of electricity, but right now it is not a socket of electricity. It's just a door for the communication. Right? So this is the first answer. And later we will then have for the answer for sure. And this one, how a non-persistent HTTP connection differs from a persistent HTTP connection. Same, I try to find one. All right, this one, okay. Non-persistent, for each object we need to have the new connection. That says connection open, then connection close. For non-persistent HTTP, we should have a new connection for each object. Here, request, in fact, we should call it should be object. And for persistent, actually, we can have multiple. In fact, if I try to have some correction, request should be changed to object. And the multiple request change it to multiple objects. All right, so this is the answer for you. And in fact, I think tutor return the result to you for checking. If you still have some question, you can contact him. Well, this is the result from you. And today we don't have any collection anymore, so it won't be necessary to join the activity. All right, so this is the closure for the previous activity. And right now, let us start the discussion today. Well, we talk about application layer, so of course we should have some apps. Well, check it first. And finally, maybe one question here, your favorites. In fact, any one thing you are interested in, then I think it will be your favorite network layer app. But I think all of you have the understanding for all for the apps here. Well, first, mostly we will ask you to create the network app. All right, so you need to have a program, right? And for each end system, you need to have the program, and so that the two end system can communicate with each other. So this is the network app. If we have the network app, of course, you should understand it won't be necessary to write software for network code devices. You cannot touch it, so it won't be necessary for you to have the program for network code devices. Why? This one can speed up the development of the networking because you just care about the software for the two-end system. As for the others, it won't be the responsibility of you. So it will be easy. Because of this way, so right now you can understand the current status for networking. We have a lot of apps, and we can have the easy way to have the communication. Well, it says, look at the current picture. We can have the host and system. Of course, for the end system, we should have 5 layers, right? For the 5 layers, they can communicate with each other, and we don't care about the code of a network. Even for the mobile system, we can have the direct communication logically. Here I call it logically because we should go through routers, devices, and switches, and so that we can reach the server or the destination. Well, so we want to ask you to have the program. To have the program, then we have 2 paradigms. The first one called client server. I think you understand this paradigm. Well, previously we already have the key word paradigm, but right now if we have a client server, the assumption should be server we expect it should be always on host. And it should have the permanent IP. Or otherwise, if we have the dynamic IP associated with the server, you still cannot connect to the server, so it won't be okay. And for the server, if possible, we want to have the beta scalability. For scaling, then we should put the server to the data centers. However, data center, can you build the data center? Normally, no. So it doesn't mean you should have the data center, but still you can have the server. And the server should have the permanent IP, and it should be always on. So this is a client-server paradigm. Also require a client. For you, I think you understand you are always maybe not always. You are a client, so you can contact, and perhaps you don't want to connect. So it may be intermittently connected. And also you can have the dynamic IP possibly. And here, this is important. Not communicate directly with each other. What it means with each other. The current client cannot communicate directly with another client. It should connect to the server first, even finally some other interaction with the other client. So this is the paradigm of focus, client-server. Well, possible example, we can have the apps using HTTP, using IMAP, using FTP. For example, HTTP, you need to connect to the server. Client needs to connect to the server, download the files, and then the client can show the possible content from the server. All right, and so that it is the client-server paradigm. Well, this is the first paradigm. And second one, yes, we can communicate with the other clients directly, and it won't be necessary to connect to the server, and so that we have the peer-to-peer. And so that we have the shorthand P2P. Well, P2P, if we have the pure P2P, and then we call no always on server. Why I mention this? For you, maybe finally you can find some possible example. You still can have the server. Why? The server needs to know the possible members, and the other client should connect to the server to know who you can connect. But here, we don't have that situation. We have the pure P2P. For the pure P2P, yes. No, always on server. All right, so only for pure P2P. However, if it is not pure P2P, we can call. We should have the hybrid. Hybrid P2P. But we don't mention hybrid P2P here. We just mention pure P2P. So of course, no always on server. Of course, for the P2P, we should have the communication direct. So we can have the communication between the two end systems directly. Well, as for the others, I think you can check it. And here, scalability. Scalability just says, how about size 1? For example, size 1 for the network was okay, and size 2 okay, and the other size, if we can take care of the different size, then we have a good scalability. And here we call self-scalability. Because of P2P, how about we form the network here for some peers? Yeah, it's okay. And how about the other? Yes. So No problem. So that says we have the cell scalability. Well, so this is the second paradigm P2P architecture. Well, for client server, for P2P, in fact, we can have the process. If we have the app, then we can have the process. And the process can have the proper communication with the other process. And so that we have the process communication here. Well, look at this, we have a process. I think some of you know what it means, a process. And here, we don't know it's a program running within the host. For some, actually for some apps. For the process, actually, we can have this one. Within the same one, then we can have the inter-process communication. And the inter-process communication defined by the OS. So we can use that way to have the communication for the two processes within the same host. And today, because of networking, so of course we should consider process in different hosts. And so that we should have the circuit programming. So this is the purpose for us. Well, so we have the process. If you don't have the networking issue, then we should have the inter-process communication. However, if no, then we will have circuit programming. Later we can let know. And even for B2B, we still have the process. But before that, we already have the client-server paradigm. For client process, so it's a program for the client and initiate the communication. And for server process, of course, need to accept the request from the client, and then client server can have the proper communication for some app. Well, here we talk about client server paradigm. Of course, we need to have two programs for the client server paradigm. Well, I think you understand the client server paradigm. We should have one program for client and one program for server. And here, look at this. Note. How about P2P? It says P2P architecture have a client process and server process. What it means? For client need to have a client and server. P2P for each peer, it needs to have the original client and server process. And for the other peer, same. If we care about two nodes, how many processes for the P2P architecture? It's 4. All right, so here for client server, we have 2 processes regarding the two end system. However, for the P2P architecture, we have 4. Right? Each peer, it needs to take the responsibility of a client and a server. All right. It doesn't mean we should have the communication simultaneously for the client mode and for the server mode. No, but we need to have both of the modes for each peer, so that we have 4 processes here. So we care about a pair of peers. Well, if so, then it says, look at this. Right now, maybe I'm a peer and want to have the communication with one of you. If I want to request some service, so the role for me, I am a client. However, maybe one of you can initiate a communication with me, and so that you are a client, but right now, I am a server. So for the P2P, actually, we have a situation like this. So that's why we should have a client process and server process for each peer. All right, so this is a process for client-server paradigm and for P2P architecture. Well, that's it. So let me start here and allow you to have maybe this time 2 minutes to have the discussion within the group. Okay, so you can have the discussion now. Let me set the timer. Okay, so maybe check it after now and questions. You can have the discussion directly. Well, in fact, we ask you to share videos, but I still go through some slides quickly. Maybe you feel quickly, but I still go through the slides, right? However, to the current page, I still ask you to have the discussion with your members. And let me try to share the understanding. So right now, any questions? I do not have the arrangement for the poll to verify for the question, but ask you the question directly. Well, if no, I assume everything's okay, so let me go to the next page. Circuits. Well, after now, we have a process. Process, we can have the communication directly. So that's why I check the responses for the question about the understanding checking. Most of you can have the end system to have the communication, but I know those answers. However, reach some answer like this. We have a process. Process needs to send some message or receive some messages. However, we should rely on one door, and that door is called circuit. Alright, so first of all, you should understand communication between the two processes, however, should go through or coming from the circuit. Alright, so first of all, I emphasize that. So, to and from the circuit, so that the circuit looks like a door here. Right? So circuit is not equivalent to the process. So this is the first thing I want to emphasize. However, if you have the process need to have the communication with the others, then you need to send message to the node and receive the message from the node, and then it is called the circuit. All right, so this is the meaning for the circuit. So of course you can have the following actions, right? Send message to the node and receive message from the node, and in fact, one on each side. So you should have one circuit for each. Here we have two AND systems. Each one need to have its own door, or otherwise you cannot have the proper message going to or coming from that door. So this one, it is a circuit. Well, about the definition or the explanation on circuit, is it okay? All right, I think it should be okay. Let me go to the next one. Before we go, sure. We have the circuit, and previously we don't have the inter-process communication. So it won't be necessary to involve. In fact, yes, but we don't care about the circuit here because right now we want to have a networking going through the internet. So we have this. And previously we have the app and process. But right now, if we have something else, I emphasize still controlled by OS. Well, circuit. Previously, I emphasized the answer. Normally, circuit should be some part of pieces of equipment. So they can provide the electricity, and that is called the circuit. But right now, it is not a type like that, but it is a type like the door in the networking. So we have this term, circuit. Well, right now, we should rely on the circuit, and later about the networking, because we have the circuit programming. And right now, let's get back to have the communication. If we have the communication, I think all of you understand we should have IP, right? And IP serving as the ID. Maybe I should know. Process should have an ID, but ID here only IP. Here it means ID equal to IP only. Of course, no. We should have for the actual one, IP plus port number. And then we have the ID. All right, so address or addressing, we should have IP plus port. Of course, we have a question. No, we still have the port number. Well, so we should have IP and port number. And first of all, if we have a web, then HTTP server, it should have a port number of 80. And how about the client? How about the client? Any idea? Yes. It says it doesn't matter. Anyone possibly, right? The answer is yes, but anyone possibly. How you have the phone number for the client? In fact, assigned by the OS. Okay? So we can have the phone number 80 for HTTP server. However, for you, for the client will have the port number assigned by your OS, and that's it. All right, so here we just mention server port number, but we don't mention the client. That says that one can be determined by the OS. Well, about this, can further questions? Okay, I think you copy that. Understand? Determined by the OS. And in fact, we already have the other types of server, mail server. Then we have 25, and the others we have the fixed port number for some well-known apps. Here we have some example. Only for server. Alright. And later we can have the details for the client, and so that we will know some port number different from 80. So let me emphasize again. 80, so 80 we reserve it. So for the client, normally we don't have the same port number, 80. We'll have the other number, but the number will be assigned by the OS. Well, I think previously we can have the protocol, and protocol should define something. Here we have types of message exchange, syntax, semantics, and rules. You can check it, so I go through quickly. And for the protocol, we can have the open protocol, but sometimes it's not open. We don't call it private protocol, we call it proprietary protocols. Proprietary protocol including Skype, because previously for Skype team, the teammate, actually that team does not provide the details for the protocol, so that we call it the proprietary protocol. Well, what that means, proprietary here. Alright, so if you want to refer to Chinese, I gotta know that. Therefore, we can have the open protocol or proprietary protocol, and we can have the proper icon so that you can have the clear definition for a protocol. And for all the apps need to rely on the lower layer. The lower layer should be the transport layer, and the transport layer serving as the service provider to the app layer, right? So here, I don't know, we should have the service provider for an app. And who provides the service to that app? It should be the transport layer here. Therefore, we should discuss transport service provided for the app. Well, we will have many possible requirements for the service provided. First of all, data integrity. We should have the exact data, not the incorrect or maybe partially correct data. So 100 reliable data. Is it 100 reliable data? If so, it is one type of data integrity. Or maybe no, it doesn't matter. Well, but you can tell me how, and then I receive it. Of course, we can have at least two types: data integrity and timing, to receive it within a time period or not. Throughput. What is the rate of the throughput? Can you provide the minimum rate, or maybe you should have some level of the throughput? Talking about the requirement, then we can have the possible service, and so that we can have the transport service. And the actual one can include security. Can you have the encryption, decryption, and of course we should have the description. The others, well, integrity here. If you want to have the 100% reliability, and then we care about integrity. Well, if we have those items, then we can have the resultant service, and we have a mixture of all the previous requirements, and we can have the different service. In fact, we should have the mixture to have the different service. However, if we check this for the file transfer, can we have data loss? No, no data loss. How about throughput? Here, elastic. Elastic means we can have any value. So elastic. And how about time sensitivity? No. You can only have it at any convenient time instant. And likewise email. And likewise web document. However, for real-time audio and video, we can tolerate loss. Alright. And how about the throughput for audio video? We can have the range. And how about time? You can have time so of course we can have the timing set for the audio and video. And likewise for streaming. And maybe similarly for interactive. However, for text messaging, no loss for sure, and the rate actually is elastic. However, for time, because of messaging, of course, we are waiting, so you cannot, then you have the response to that. So we have the timing associated with text messaging. Well, up to now, something like we consider some different X. Here we have X, and X with the different requirements. All right. With the different requirements, and then we want to have the mapping. Any transfer layer to serve the apps, and so that the app can meet. The app can have the proper meet requirement, and so that I can choose, for example, one of the service. And here TCP claims. Well, I can provide the following service: reliable transfer, flow control, congestion control. As for the others, transport does not provide, including timing, rate, and security. Alright, so this is a service claimed by TCP. And finally, TCP mentioned, I should have the connection. You should establish the connection before you want to have the communication. Well, I go through quickly. Reliable transfer provided by TCP, flow control by TCP, congestion control by TCP, and TCP need to have the connection oriented process. And for UDP says unreliable, and I don't provide the others as well. Finally, we have a question here. Well, this a UDP you claim you don't have the specific maybe service here, but why we should have UDP? Faster is correct, but at least if I have a TCP service, and you should have the others for sure, right? And you can think one simple one, something like is UDP. So faster is correct. If we have a UDP, we can have the faster communication possibility. As for faster, why later we can explain. But at least we should provide the other options. Alright, so even it's really simple, and it seems to be no specific service here, but we still need to have the option, and the option is UDP. If you don't think so, you can have the other option as well, and so you can have the TCP, UDP, and the others. In fact, yes, we can have the others, but we just mentioned the two. The two, it doesn't mean we just have the TCP and UDP. No, we still can have the others. Even you want to define for you to have the actual one, is fine. But right now, we already have TCP and UDP for maybe initially for simplicity. Because if we want to provide two options, at least we can provide TCP, we can provide UDP, and the UDP actually can have the faster communication for sure. Well, so about the answering, is it okay? Maybe for some reason faster, at one extra option. So we have a TCP, UDP, but think about this. Even for TCP, we don't have a timing. We don't have a minimum throughput. However, for the apps, some of them are asking for the minimum rate and how to guarantee, for example, the minimum rate. First of all, if you want to guarantee, sorry, TCP, I cannot guarantee this. If TCP doesn't know, I cannot guarantee any possible solution to guarantee the minimum throughput by network layer. If yes, raise your hands. By link layer? By physical layer? No, right? Oh, yes? Okay, by physical layer. So, one of our students mentioned by physical layer. However, by the app layer, actually by the app itself, or what you by OS. So here, maybe let me have three options. By layer lower than the transport layer, and by OS, and by the app itself, the app layer. Which one you prefer? So first of all, layer lower than transport layer, maybe one, right? Physical layer. So maybe one. And by OS, maybe a few. By the app layer itself, no. Well, the answer is yes, by the app layer itself. For example, here, I request a throughput guarantee. Can you guarantee this? Transport layer, let me know. No. And in fact, it's impossible for lower layer. All right. By OS, in fact, you can think about, yeah, by the app, and the app maybe should have some implementation by the OS, but not many by OS. But should implement by yourself. Well, I need the service, but you cannot provide it. However, I want to use it, so I should find the solution by myself. So yes, by the app layer itself. All right, so this is concept I should pass it to you. If TCP cannot provide the minimum rate guarantee, then the app layer should find the solution. In fact, some other discussion can directly have the solution. I just mentioned we should do something like that. For UDP, yes, if we have a UDP, then the app should consider if we want to guarantee something else, the app should take care of those things. Well, even we have some service, but finally, no choice, we need to choose one. Previously, we have all the service here. We have the final mapping. TCP, 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 or UDP, TCP, UDP, or TCP. Well, here I want to make sure. For file transfer, we have only choice, TCP. Why? Yes, reliable. Reliability, then we choose TCP. And it should be the same reason, TCP, TCP to TCP. All right. Because of reliable data transfer provided by TCP, so the three types of service choose TCP. And maybe for UDP, you don't have any fixed UDP. Why? In fact, UDP is just an option, and maybe not satisfy all the requirements, so it doesn't mean we should choose UDP. But look at this. if we have the priority set for interactive games, normally we choose UDP first and then TCP. Why? Faster. Yeah, correct. Why faster provided by UDP? Because TCP has the congestion control, and so that it throttles the rate, maybe lower rate, so that you can proceed faster. So UDP, yes, if you consider the factor of fast or not, faster, then you should choose UDP. And faster for UDP interactive games, even for audio video, we should choose UDP. However, for Dash actually based on HTTP. Because of HTTP, right? So of course Dash, we choose TCP. If we don't use HTTP, actually audio video interactive games, internet telephony, normally we prefer UDP because of faster. Alright, and here we have the other option. If you don't like it, you can use TCP, you can use TCP, but normally we can have a UDP only. But someone doesn't like it, so we still have a TCP. But normally, the first priority should be UDP. And then we have one more question. How about network management? If we are asked to have the TCP or UDP to support the apps for network management, so which one you think you should use? Management for networking issues. Network management. For example, you want to monitor the status of the network. Yeah. So for that issue, then you have network management. And which one you prefer, UDP or TCP? One, TCP. Any other? UDP. Of course, you should understand TCP or UDP. In fact, I like this, but finally for network management, we prefer UDP. Network management, it's UDP. Why? Well, I want to monitor some status, but finally, because of network congestion, you cannot receive anything. However, if you choose TCP, no, you don't let me have the answer. You don't let me have the answer. You don't let me have the answer. So I wait for your answer. If so, then network control or network management should take time for control and consume all resources. If so, not okay. Why not okay? If I want to monitor the status of the network. At this moment, I can have the record, but I will check it frequently. So next time, I still have the chance to check it. Basically, I don't have the answer, but right now I can have the answer. It's still acceptable. Because of all of the reasons here, finally for network management, we will choose UDP. All right, so that's it. Network management, normally we will set UDP for the app. All right, that's it. So let me start here. And before we have we take a rest. Any questions? If no, take a rest. Well, this is the mapping for service if TCP and UDP only, how to have the mapping to the apps? Well, about the mapping, is it okay? All right, so let me go to the next one. Well, TCP claims we don't have any security support. So here we have the original TCP we call vanilla TCP or vanilla UDP. In fact, it won't be necessary to have vanilla, that's okay. Up to now, for the TCP, we don't have security, so no encryption. It's the clear text even for the password. So if we want to do so, you can have the transport layer security, TLS, and so that you can have the encryption, data integrity, authentication, and to have TLS, of course, you have a TLS. The app needs to have the libraries. And the library need to use TCP. So here, if you think we have an app layer, the app layer call for the service for TCP, but TCP cannot provide the security support. So something like TCP. And we have TLS, and then it's app layer. Well, sound like we have some extra protocol above TCP, but still within the transport layer. All right, so if so, then we can have this. And it says, if we want to have anything else, you can refer to chapter 8. So we mention it, it doesn't mean we want to know all the detail, but we may have the TLS. Well, up now, we need to have the attendance checking before we have the activity of group discussion. So that's it, check it. 3 minutes. Maybe shorter than 3 minutes, but check it. Only within the current 3 minutes. If you fail to key, then sorry, no chance. And you can use app, and so that the app, you can key HUI-WEN-FENG-451 directly. If you have the app. Yes, you should have the name and then your ID. So let me check. Anyone not finished? Still have a few seconds. So check again, not finished. Okay, so good. So next one, we have a good discussion to ask you to check the problems from our task book. And you should understand right now you can check lines that you have the solution to chapter 1 as well, right? So if you want to rely on some of the solutions there, you can check it. Well, of course, you can check your line, or maybe you can scan the QR code to have the problem. Maybe you can scan it first. And we can rearrange the seat, or group 1 you can sit together. And group 2, almost okay, but group 3, yeah, okay. Group 5, okay. And good. For those, okay. And good 6. Well, we have 6. So you should be 5, right? Alright, I thought, sorry. 4. 5 these I can say 5, 6, 5. Okay, and 7. So sit closer, and so that it will be easier for you to have the discussion. And right now, I have the assignment. So I think you have the problem, right? And problem 1, today I assign to group 1. All right. Problem 1 assigned to group 1. And problem 2, A and B assigned to group 2. A and B. I think so, A and B to group 2. And we have C. Later I will mention to C. And problem 3, A and B to group 3. And right now, we have problem 2 and problem 3, C. C assigned by group 4. So group 4, problem 3, C, and problem 2, C. And problem 4, A and B by group 5. And CEE by group 6. And problem 5 by group 7. Okay, so up now this is the setting. Problem 1 by group 1, 2, AB by 2. And group 3, problem 3, A and B. And group 4, problem 2 and 3, C. And group 5 is problem 4, AB. And group 6, problem 4, CDE. And finally, problem 5 by group 7. All right, so you are assigned the corresponding problem. You can have 5 minutes to have the discussion and prepare the answer. Okay, go and check it. 等一下每个人都要在那个 for algorithm 他就是里面的反正我讲话，他就先讲，他那个数学的时候，这16条，而且是跟隔壁他会讲他，就是最大的，So later, all you need to key your answer, but focus on the problem you have. As for the others, you can key skip. One should have the presentation, but all need to have the answer to all arbitrary. Yeah, that's it. But one. As for the one, right now you can join Teams. 他报告的人现在可以加入 Teams， 但只有7个就好了。他说不要全Your course.
The first question of the answer will be circuit switch networking would be more appropriate for this application because of the constant and steady data transmission and long running sessions. In construct, packet switch network dynamically routed data packets, which would introduce delay, jitter, or variations in bandwidth due to the network congestion or very packet routes undesirable for an application that transmits data consistently over a long duration. And the second question's answer will be congestion control in packet managed switch network. Even though the sum of the application data rates is less than capacities of each end, every link some form of congestion control may still be needed because of dynamic variations in packet arrival times, and shares resources management. That's all.
So if I want to highlight the answer, so if you want to highlight the answer, can you highlight the answer? A and B.
The first one. The first one will be circuit switch network will be better, and the second one will be yes.
So here, answer from good one, circuit switch network, and yes, and you can check it for the answer, and later we will have the solution to you. This is the answer provided by Group 1. And anyone want to ask questions to Group 1? If no, thank you. Okay, thank you. Okay. By now, we have the discussion by Group 2. Group 2 is ready, then you can have the presentation.
And problem 2 we see is picture. We see this picture. The first we see is picture 1. We can see 4 switch A, B, C, D. And the question A, what is the maximum number of simultaneous connections that can be progressed at any one time in this network? If we want to know the maximum number, we can choose A, B, C, D to connect. And we have 4 links. And each link we have 4 circuits. So the maximum number is 4 multiplied by 4 is 16.
16, right?
Yeah. So the A answer is 16. And we say B. Suppose that all connections are between switch A and C. What is the maximum number of simultaneous connections that can be over? Okay. So we see.
So, trying to have a summarized solution for P.
Yeah. Okay.
Yes.
If A switch C, we have 2 ways. The first way is A to B to C, and the second way is A to B to C. So these 2 ways, what is the maximum number of simultaneous connectors can be progressed? Okay, so A connect to C, the maximum is 4 multiplied by 2. So the link maximum is 8.
Okay, 8. Alright, so this is the answer. So this is the answer provided by Group 2 for A and B. And anyone want to ask questions to Group 2? Alright, if no, then it's Group 3. All right, so this is a discussion by group 5. All right, so if group 5 ready, then you can have the presentation.
Okay, so for problem 4, the question A answer is 12 seconds. We can get the answer from our calculation. The total message size is 8 megabit, and the transmission rate is for 2 megabit per second. So for the message itself, it will take 4 seconds to transmit for 1 hop. Since there are 3 hops in the total system, so you times it by 3. So it's 4 times 3 for 12 seconds. It's for question 1. For question B, we segment into 800 packets. So each package size is 10,000 bits. The question B has 2 small questions. The first part is how long will it take the first package to transmit for 1 switch? So the answer is 10,000 bits divided by 2 megabit per second. 5 milliseconds is because for 1 link, the transmission rate is 2 megabit per second. So the second part of the question is how long will it take second packet to the first switch? The answer is 10 milliseconds is because it will take 5 milliseconds to get first package to the second switch. And it will take another 5 milliseconds to get second package to the first switch since it's pipeline. So the first package need to be moved on first, then the second package to be transmitted to the first switch. So it will take another 5 milliseconds based on the first 5 milliseconds. So this is our answer. Any questions?
So any questions? Of course, if you want to have the answer, you can take a picture first, and then we will check if we have the solution. If I have the solution, but later I will show them. So this is a discussion by group 5. And now, so share the content first by group 4. Share your content first. Because it's my microphone, so it won't be necessary to turn on your microphone there.
Okay.
So group 4.
Yeah, I think it works. Okay, so we don't have to open the microphone.
No.
Oh, okay.
So, yeah, if you are ready, then you can start.
Okay, so for the first question, I think that's
2B. 2C.
Yeah, 2C. Okay, so the question is like, we got, so this is like a, so let me open the problem. We have a problem. Okay, anyways, maybe you can.
Yeah, we have the problem, no problem.
Yeah, you just have the problem. Okay, I'll just like describe it, I guess. Okay, so basically we have a circuit switch network. So it's not like packet switch. So we have 4 routes or 4 circuits, each link here. And the question is it possible for us to get 4 links from A to C and also 4 links from B to D? So we have 8 links in total, and but we only have like 4 by 4 each side. And we found a way to do this. So basically, you split the connections into half. So the problem asks us, is it possible to get 4 links from A to C? And basically we split that 4 links into 2 by 2. So A would go 2 circuits or 2 links from this direction, and the other 2 will go this direction. So since each link here from A to B has 4 channels, we're only using half of the channels. And that allows us to do the other side of the problem. So basically, we can go from D to D using the rest of the channel. So that's how we solve the problem on QC. Right? Is it clear? Sorry that we don't have the problem here.
So the answer is yes or no?
Yeah, the answer is yes.
Okay.
Basically, we split the connections
Okay.
into 2 routes. Right. And maybe we'll move on to the next one.
Yes.
Okay, so the next problem is asking, so it's the satellite problem, 3C. And basically we have like a station with fixed bandwidth. The bandwidth is 10 megabits per second, 10 megabits per second. And we're asked that, so we're transferring a photo every minute. And the question is, what's the minimum size of the photo that will take up full transfer bandwidth? So basically, since the transfer bandwidth is 10 megabits per second, and we are transferring every photo every 60 seconds, so we can just multiply them together. So it's 10 megabits per second, and we convert the basically convert that to 1.25 megabytes per second, and multiply that by 60, so we get 75 megabytes per minute, and that's the megabyte needed in order to fill the 1 minute gap. So the answer is 75 megabytes.
So the answer is
75 megabytes or 600 megabytes.
Okay.
Yeah, to fill the bandwidth.
Okay.
Yeah.
All right. So this is the answer from group 4.
Yeah.
Okay. Thank you.
Thank you. We'll prepare the problem next time.
Okay. So perhaps that us finish the discussion by group 3. Ready? And then group 6 and group 7 we will have the presentation this Wednesday. At least this is the first experience how to have the presentation using Teams. So group 3 ready? Share. Okay.
For question A, to get a propagation delay, we can divide the speed by distance. So the answer is 0.15 seconds. For question B, just bandwidth multiplied by delay time, so we can get 1.5 million. That's all.
Okay, thank you. So I think this time we finished the discussion by group 1, 2, 3, 4, 5. And this Wednesday we will have the discussion by group 6 and 7. And after that, and then I will let you have the solution from slides. Of course, you can find the solution because we release the solution to you. You can check live. Today the time maybe it is not properly controlled, so of course we don't have enough time to finish a good discussion. So we will have the next time to finish the discussion. And maybe next time we'll check the solution. Or maybe you can check the solution in advance. Alright, that's it. If no further questions, see you this Wednesday. See you, bye.